Wait, what are you doing?
I'm just putting some notes in my diary.
Is that like a logbook?
Yes.
That's what we're on to now.
Yes, so
Chapter 8.
Logarithms and exponentials from this book.
Oh, yes.
So, firstly,
What's an
what is it?
exponential?
Yeah.
Yeah.
So it's in the form y equals a to the power of
Put the
x.
top left. Yeah.
And if we draw the typical one you'll get, it looks like that. It never touches 0 and then it will shoot up like that.
And that would be 1.
That will be 1 because x to the power of 0, no matter what it is 1. So it always goes through 1.
Yeah.
And that's called exponential growth. It gets bigger and bigger and bigger really quickly. Yeah.
But, Wayne, what if a was between 0 and 1?
Well, that would make it a fraction, and as you times a fraction by itself, it gets smaller. That means it's the opposite. It will still go through 1, because it doesn't matter what it is to the power of 0, it's 1. But it will go the other. It will go the other way, and shoot up there. So you have it. If you have it to a minus, then it will be 1 over a fraction. So
yeah,
it gets really big.
Isn't
That's
that
called
nice?
exponential decay. Just where something gets smaller.
There you go.
Really quickly.
Really quickly.
So then we need stuff like y equals a to the x, but transforming them.
Oh.
So stuff like translation.
So how does it work here, Wayne?
Well, if you have a vector where the x part is changing, so this could be 3 and the bottom would be 0, that means the x is replaced by x minus 3. So it'll be y equals a to the x minus 3. Quite simple.
Yeah.
You can do an example if it's in the y direction.
Okay. I'll do it in blue as well.
Okay?
So if instead you were to have it from 0, 3, like before.
Yep.
It would be
Except it's not a negative 3. You actually plus it on just after, so it's y equals a to the x plus 3. Just like that.
just like that.
And that's transforming logarithms.
Yeah, will they do any others? So I just follow the rest of the patterns.
No, just follow the rest of the patterns. You don't need to go through all of them.
I've done that a few times now.
They don't often come up. But if the x up here is replaced by a 2, it's a half in the x direction. If the 2 is before the a, it's in the y direction.
Yeah, all that
The
jazz.
usual stuff. Now let's actually get on to some logarithms.
Oh,
Let's do it.
I like trees. Logs.
And all of the rules.
Yeah, and using them and stuff.
So,
Do that.
if I put up an example.
Yeah. What's a log and what do you do with it?
You can often see if I put this example, log 2, 8 equals 3. What's going on?
Well, Wayne, we sort of pay most attention to this number here. That number, the power of that number is that number.
Yeah.
So 2 cubed is 8.
If we write this all algebraically, to get from this form, y equals a to the power of x, into the log form, it's log a y equals x.
So if we have our thing here, it would be the y would become 8.
A is 2, y is 8, yep, so
Yep.
8 equals 2 to the 3 when you reverse from this form to this form. And that's something you've got to know.
It is.
To do that, that would save you a lot of time to know these two algebraic things.
Yeah, and that's the really beginning, really.
Yeah, but what I tend to do, if you don't want to remember these algebraic forms, I actually remember this example, and that helps me picture what's going on.
Yeah, work out the rest from there. So now the proper rules.
And you do need to remember all of these.
Yeah.
This number 2 in this case, but A has to be the same for these rules to apply.
Yeah. So if we have log
A
3,
3
okay,
plus log A what?
2, I think.
Okay.
It doesn't become log A5.
It doesn't, no. You've got to times them together rather than add them together, just by the laws of logarithms.
Yeah, which that makes it log A6, which isn't 5.
Similarly, you can probably now work out
if you minus them.
log A3 minus log A2.
Divide them, so it becomes log A 3 over 2. You don't often get fractions in logarithms, but you do. They're here.
Yep. And there's a final rule you have to know.
There is, and that's when you involve K.
The K's are always scary.
K's are always scary. They always mean stuff's
Okay.
about to go down.
2.
Or you're using the discriminant.
That's cool. 1,
One of them.
2 to the K. So that rule, that K is the power of the final number, essentially.
Yeah.
So, we should do an example.
We should do an example.
Now, in the form you'll get in an exam, maybe,
Not always, maybe.
is something like
Drum roll, please.
4 to the x equals 28.
You got to find out what the X is.
And it will ask you to do it using logarithms in the exam, and it always says that.
Yep.
So then you know where you are, you know where you stand.
Yeah, so, like before, we want to convert to logs.
So you want to log each side. Log 4x equals log 28. In this case we don't have the little a's here.
No.
What you can do is you notice from our rules before with the k, you've got to get that over here, so it's x lots of log 4 equals log 28. Then, to get x, you do log 28 divided by log 4.
Then the logs cancel.
No, it doesn't
No.
quite work like that.
Oh.
The laws of logarithms is if you minus them, they do the divide thing. So if you do the divide thing, it can't do the divide thing, because that's what
Minuses.
subtracting do. So you actually have to type into your calculator log 28 divided by log 4. It's not the same as log 4 divided by 28, which would be 6, 7? 7. That's not the same as log 7. So let's do that. Log 28, there it is, log 28 divided by log 4, 2.4. This part you've got to do on your calculator. But you've got to notice you've got to take logs of both sides. From there,
Yeah.
it's quite simple.
It's all new stuff.
But now that we've done this example, I think we can go on to a test yourself and do a proper exam style question.
I think we can. Let's do that. Question time.
Test yourself, page 115, question 5. Oh.
I've usurped Wayne. With a pen. It's not in my hand. It's
From this book.
from that book.
So question 5, if you want to read it.
Sad day. Right, yes, question 5 says that given that log a to the x equals log a 5 plus 2 log a to 3, where a is a positive constant,
Okay.
show that x equals 45.
Okay. Really, we can ignore the a in this example. We don't really need it. It's
No,
just to
because-
prove that they're all the same. So, plussing. We know from our logarithm laws what that means, Triv, and what's that?
Well, it means you times them, but first,
First?
we got that bit.
Oh my goodness. That's the same as log a3 to the 2.
It is.
3 to the 2 is 9.
It is. We did that step first.
Should have done. I didn't notice.
So now I've done that, well, I could just put that in below.
Okay,
So that's the same as log a to the 9. And then we can do the next step.
so that log
A to the x equals log a. 9 times 5 is 45. Oh, I've done it.
log council.
And that means x equals 45. That's the answer.
We've done that one.
Excellent. Alright, part 2.
Okay. B.
Oh yeah, there's 2 parts to B.
Oh. Okay.
Sorry.
Part 1.
Is write down the value of log 2.
Log 2. 2.
Right.
That means converting back into this form up here.
It does.
Y equals a to the x. So,
Yes.
a, which is here, 2 to the power of something
Equals 2. Now what you could do here was put logs on both sides, which all
Yeah.
the steps did before. But
You should be able to see.
rules of indices, anything to the power of 1 is itself.
So, x equals 1.
Yeah, that's the answer. So there's a B part 2 as well.
Oh, yeah.
And that is, given that log 2y
My goodness, log 2y
equals log 4 2,
log 4 2.
Find the value of y.
Now that's a tricky question.
Got a few steps for this one.
Yeah, I'm thinking how to start this one off.
Well, Wayne,
Are we converting back into the other form?
I think that'd be sensible.
Yeah. So, 4 to the power of something equals 2. The rules of
Yeah.
indices show that that something will be a half.
It would, because it's the same square rooting it.
That means log 2y.
2y equals a half.
We essentially
Yeah,
did what we
second
did
step.
in part 2, but with this one.
Yep, and then we can do the thing again.
Yes, sorry. 2 to the power of something equals y, but we actually know the something now.
We do. So
2
to the power of a half equals y. So we know what that means.
That's just the square root of 2.
It
so
is.
y is root 2.
And that's the answer.
Yes, and as usual, as much as we can, this is from an actual exam paper.
It is. It is from
Question 5.
2002.
So could come up, could
come
be
up.
this hard.
Yeah.
That's what we like to try and do as much as we can.
And it's been logs.
So I think just sum up.
We should. Let's do it.
So,
Logs.
and exponentials.
Yeah, we started off with the graphs, exponentials, what they look like, and why they look like that.
Yeah, exponential growth and exponential decay. Decay happens if it's between 0 and 1, because that's
Yeah.
a fraction.
And
Makes sense.
growth happens when it's higher than 1.
Yeah, and it just shoots up, and it always goes through the point 1.
It does, because anything to the power of 0 is 1.
We then looked at actual logs.
The actual logs, and what log was, we used the two things up there.
Yeah, you won't be able to see them because you're looking down here.
Aye.
Unfortunately.
But if you look back at the video, they'll be up there. Those things.
Y equals a to the power of x,
And that example was log to the 39 equals 2.
i.e. 3 squared is 9.
Yeah.
Rearranging it.
That's it.
All of the log plussing it is times, minusing
Anything
it
is
is
divide, scale it, the
Yeah.
same as having a extra
square
indice.
thingy, yeah.
Yeah.
Then we did a few questions. We did
We
a
did.
worked example followed by a test yourself
Again, an exam from an exam.
from 2002 this
Yep.
time. So it could come up and do come up quite often in all
Yeah,
the
they do.
in all the recent ones I've gone through.
Logs are often a question by themselves.
Yeah.
Just on logs.
Much like in core 1, you normally get surds on their own.
Yeah, it's like
Sort of an 8-mark question.
They do it in logs.
I don't know how many marks it's worth, I can't remember, but
No, I
it's
can't
probably
remember.
about there somewhere.
Yeah, 6 to 8, I reckon.
So they come up.
Did you?
Not a massive chapter though.
No, they're not that hard, but they are new.
Yes, that's the only thing that's scary about them.
Yeah,
They're new.
they're new.
Few rules.
Few rules, and
It's a lot like surds in core 1 in fact.
it is very like
In
Surge
terms
and
of-
Core 1. Use it much more next year, but we'll get to that when we get there.
Yeah.
Yeah.
So for now, it's been Wayne Lack.
James Trevett,
We'll see you at
Calculus Squared.
differentiation and integration's the next topic.
Alright, let's crack on.